this problem, we're going to find the second derivative using implicit differentiation. We know that it's the second derivative because of the number 2 in the usual derivative symbol. So what that means is we're going to find the derivative of y, and then once we find that derivative, we're going to find the derivative of it. So we'll just start as normal using implicit differentiation. The derivative of 3x cubed, multiply the exponent out front. So 3 times 3 gives us 9. And then decrease the exponent to a 2. And then the derivative of minus y cubed, multiply the 3 out front. Decrease the exponent by 1. And anytime we take the derivative of y, we have the derivative of y with respect to x, dy dx. And then equals the derivative of 2, any derivative of a constant is always 0. Okay, and then what we need to do is go ahead and solve this for dy over dx, the derivative of y. So we can do that by subtracting 9 squared to the other side. And then lastly, negative 3y squared is attached to dy over dx through division, or sorry, through multiplication. So eliminate with division. Okay, and then cleaning up, negative 9 divided by negative 3 is positive 3x squared over y squared. So there's my first derivative. Again, for this problem, we want to find the second derivative. We do that by finding the derivative of the derivative. So I want to take 3x squared over y squared and find its derivative. Okay, so here we have a quotient, so we're going to use the quotient rule. So my top is 3x squared, derivative of that, multiply the 2 in front, we get 6x, decrease the exponent to a 1. And then we have our bottom is y squared, its derivative, multiply the 2 in front, and we took the derivative of a y, so dy over dx. Okay, so using the quotient rule, I have that the second derivative of y with respect to x equals du times y squared minus the derivative of v, 2y dy over dx times u all over v squared. Okay, now to finish, we do not want to leave our answer with this dy over dx term right here. Okay, instead we're going to use substitution because we know from our previous work that dy over dx is 3x squared over y squared. So we can go ahead and make a substitution and do some algebraic simplifying. So here we have 6xy squared minus 2y times dy over dx is 3x squared over y squared. and then we still have our 3x squared term here. And then all of that divided by y squared squared is y to the 4th power. Okay, some of the simplifying I can do in the numerator. We have this y and this y squared. We can simplify those, and then we can multiply the constants and combine the x squared term. So what we have then is 6x y squared minus 2 times 3 times 3, that's 6 times 3 is 18. And then x squared times x squared is x to the 4th power. And then y over y squared, this y will cancel one of the two from the y squareds, leaving this as over y. And we still have our original denominator here, over y to the 4th power. Okay, the last thing that we need to do is to go ahead and simplify this because I have a fraction within a fraction. To do that, I need to cancel away this y on the bottom. I can do that by multiplying this term by y. So if I multiply the entire numerator by y, and I multiply the denominator by y, algebraically, that means I haven't changed anything, because y over y is 1, but it allows me to simplify. Okay, so I get 6xy squared times this y out here. Y squared times y, I'll make this 6xy cubed. Minus, whole point of doing this is this y and this y cancel, leaving 18x to the 4th. And then in the denominator, I have y to the 5th power. And there should be my final answer for my second derivative of y with respect to x.